Hi once again. I'm sure you're probably as disappointed as I am that we have reached the second to the last topic that we need to talk about this semester, and that is the idea of geometric sequences. Now, in our last lesson we looked at arithmetic sequences, and we noticed that the defining characteristic of arithmetic sequences is that there's a common difference between each of the terms. In other words, we can add the same amount from one to the next, and that is how we define those sequences. Now, with geometric sequences, we have a common ratio in there, and that common ratio is the ratio of two terms, just like in 9.2 that common difference was the difference of a sub k plus 1 and a sub k. Well, the common ratio here is going to be the ratio of a sub k plus 1 and a sub k. So again, very similar way to get from one term to the next. We simply multiply a term by its ratio. So if we are at the second term, we multiply it by its ratio, we get to the third term. And so with that in mind, we see the formula for the nth term starting in our first term and multiplying that first term by n minus 1 factors of that ratio. Now, if we were at the kth term and we need to get to the nth term, so if we're at the fourth term, let's say, and we need to get to the seventh term, we would multiply that fourth term by 3 factors. 7 minus 4 is 3 factors of a sub n. So these are two formulas here that you'll want to keep track of as we go. Some examples of geometric sequences: 36, 12, 4, 4/3. Notice here each time our ratio is 1/3. Here's another one: 5, 10, 15, 20, 25. Notice here our ratio is 5. So we are asked to find the nth term, the fifth term, and the eighth term of this particular geometric sequence. Well, the formula here that we'll start with, a sub n equals a sub 1 r to the n minus 1. And so in this case we need to find r. Well, let's see. R is a sub 2 divided by a sub 1, so 1.2 divided by 4, and 1.2 divided by 4 is going to be 0.3. So now that we've got a ratio, we know what our first term is here. We're looking for a sub 5. A sub 5 equals the first term, which is 4, times 3/10 to the 5 minus 1. And when we multiply this out, we get 0.0324. If we're looking for our eighth term, a sub 8 equals the first term times the ratio raised to the 8 minus 1 power. The first term is 4. The ratio is 0.3 raised to the 7th power, and so we get 8.748 times 10 to the negative 4. That is our eighth term. Questions there, make note of them and bring them to class. And let's look on down again. We'll find the nth term, the fifth term, and the eighth term. We need to look for our ratio here. We'll look at the quotient of a sub 2 and a sub 1. Negative x over 3 divided by 1. Well, that makes it nice and easy. That's negative x over 3. And so looking for the fifth term here, we've got a sub 1 r to the 5 minus 1. A sub 5, well, a sub 1 is 1. The ratio here is negative x over 3. This is to the 4th power, and so we get x to the 4th over 81. If we want a sub 8, we've got the first term, r to the 8 minus 1, so this is 1, negative x over 3 to the 7, and this gives me negative x to the 7th over 2187. continuing to use the results that we have just worked with. If we look here at this third example, find the specified term of the geometric sequence that has the two given terms. Well, notice here that we're given a sub 2 and a sub 3. So our ratio here, I can look at a sub 3 divided by a sub 2. I'm looking at negative root 3 over 3 for my ratio. And I need to find the seventh term. Well, if I need a sub 7, first of all, let's remind ourselves, a sub n equals a sub k r to the n minus k. So here I'm looking for a sub 7, and I can use either the second term or the third term. I'm going to use the second term, just 3 is a little nicer to work with than the square root of 3 is. So we've got 3 times a ratio of negative root 3 over 3. This is raised to the 7 minus 2 power, and when we do that, I'll let you guys fill in the details, but we get negative 1 over 3 root 3. Now we take a look here at our next example. It says find the specified term of the geometric sequence where the second term is 3 and the fourth term is 6. And so we're going to want to find a sub 8 here. Well, let's see what we've got going on. Now normally r would equal a sub k plus 1 over a sub k. But since we've got a sub k plus 2 over a sub k, because what we've got here is a sub 4 over a sub 2, then this is going to give me r squared. My exponent here is going to match, thinking bubble is going to match the difference of these two subscripts here. And so when we look at this, r squared is going to equal 6 over 3, which is 2. That means my ratio is the square root of 2. And so if we are looking for the 8th term, let's remind ourselves we can start at the 6th term, r to the 8 minus 6. Our 6th term here, I'm sorry, I guess it's not the 6th term that we know. It's the second term or the fourth term. So let's switch this up here again. I'm going to go with 2, not that it really matters. But a sub 2 here, 8 minus 2, so a sub 2 is 3. My ratio is the square root of 2 raised to the 6th power, and when you multiply that out, we get 3 times 8, which is 24. So there is my 8th term. And so a couple problems to work for class discussion, a couple problems to work for homework, and a couple more theorems here, formulas that we need to master. The sum of the first n terms can be found by taking the first term times the ratio of 1 minus the ratio raised to the n power divided by 1 minus r, and then the sum of an infinite geometric series, the first term divided by 1 minus the ratio. So we look here at example 5. We're told the first term, we're told the ratio, and we want the sum of the first 8 terms. So very straightforward. The sum of the first 8 terms. The first term is 17 over 16, and then this is going to be multiplied by 1 minus a ratio of 3 raised to the 8th power divided by 1 minus 3. And you work this out, you get 3,485. So that's the sum of the first 8 terms there. We look at example 6. Here we've got a sum that's going from 1 to 7. So basically we're finding the sum of the first 7 terms. And so the sum of the first 7 is our first term, which our first term here, note, a sub 1 is going to be 3 to the negative 1, or 1/3. So this is going to be 1/3 times 1 minus the ratio to the 7th power divided by 1 minus the ratio. So we've got 1/3 times 2186 divided by 2187 all over 2/3, and that works out to be 1093 divided by 2187. So that's the sum of the first 7 terms. And believe it or not, guys, 3 or 4 little formulas there to learn. 9.3 goes by fairly quickly. So if you have questions, certainly make note of those, bring them in, and we'll be glad to go over them.